My name is Sergey Kuksenko, and I am from Oracle. I'm working on Java performance on different aspects, so it depends on which projects I'm exploring right now. Here on that presentation, I wanted to use a show as example, as a live example, which I did for one project, how we performance guy work with code, what we do at the first. Like, not try to explain you some kind of performance methodology, how to do it. But just to show one example without some theoretical thinking, etc. Okay, I really love that slide. Probably you're already tired of such things. I have seen that slide very many times, but I love it because it means I could tell you anything what I want, and nobody will blame me for that. Okay, so I'm working on Java performance for a long time, and on Java etc. a little bit more. So here I want to talk about HTTP2 protocol. Of course, at some moments we have to touch some details of that standard because of its real example. It's how we deal with that, but it's not our goal. We are talking about if Java application, Java libraries, some components of the system, and what we are doing with that. Also, I want to talk about new HTTP client, which appeared in Java 11. I talked about that client API yesterday, from user point of view. And I just want you to show one example how to deal with performance. So, how goal for such project usually specified. So we have to provide reasonable HTTP client performance with reasonable cost. Not all projects so lucky for me. Sometimes I have demands to do something more extreme than reasonable. But reasonable it's very lucky because I could choose what reasonable means. For that particular project, our goal is to make a new API which resides inside GTK, inside standard Java API, and provide comparable performance with all our competitors. We don't need to outperform competitors. The performance should be just reasonable, should be okay. That's enough. So, I have a project. I have some code. It's a new code, completely written from scratch. And I have a goals to start performance activity, to check performance for that project, to improve performance. What should I do first? I could read HTTP specification because of how I could tune code which do something according with that specification without knowing details of that specification. I could go into code to make review, rewrite bad things. In any project with any brilliant developers, there are bad code, particularly if it's just a fresh code. I could say, oh, it's total crap and rewrite it from scratch. Sometimes people do that. What do you think? What should I do first? Who is the vote for reading specification? And who for evaluating the code? No. Our first goal is benchmarking. Because of performance engineering, performance methodology is everything is based on experiment. Without experiment, you don't know your performance. It's practical area. Of course, there are some theoretical things like theoretical complexity of algorithms. And there is some things that theoretical complexity of algorithms has a correlation with actual performance. But not always, unfortunately, in our days. That is why we definitely need some baseline. We need experiments. For that, we have to make benchmarks. So I wrote benchmark, just quite a simple benchmark, which send HTTP request, get, and post because of a different direction, plain and cell connection, etc., etc. I used JT server because for me just more convenient to use Java-based servers than something else. It doesn't matter in that area. And check it. And as other question, what we are targeting. particularly for that area, there are two different targets. First of all, it's overall throughput of systems, how many requests per second we could achieve. And the other goal is latency, the response time for each individual response. That thing should be measured in different ways. Throughput, it's much easier to measure. And after some discussion, we decided that we shouldn't care about latency. Throughput is average latency, but it's not latency at all. And because of its client code, and we shouldn't take care a lot about spike latencies, etc. Later we'll talk only about throughput. So I did benchmarking. And of course, what I do at the first, I'm not starting reading specification again. I just want to execute that benchmarks can understand if everything is fine. Because if everything is fine and performance already good, maybe I should do nothing and close that ticket. And here my first result. On that laptop with localhost, I've got 25 requests of 1 byte per second. Is it a nice performance? Okay, I'll start digging. First thing which I'm doing, just to understand what's happening around, just checking competitors. It's very nice if you have competitor of something similar software, because you could benchmark that, you could compare that, and if that thing works faster than you know that it's feasible to achieve high performance. You may start digging. If you don't have a competitor, to make a choice, is that a limit of your work, or you could do it better. Okay, probably something wrong in our client. I measured it on other platforms, just to be sure what's happening. And I see that Windows finally outperformed Linux. The same code. Depends. What happening? Are there some guys who are working on networking things heavily? You should know, probably. So as for me, I usually work with assemblies and CPU things. So for me, it was my first networking project. I have to spend some time to dig and find out the issue. The issue was at that piece of code. So here, our client opened socket channel to server for further transferring bytes. Is there someone who knows the issue at that place? The issue is that absence of that line. I definitely tell you that it's not easy to understand what's happening here without knowledge. Only Google could help you. So here we got a very well-known issue for TCP network stack. It completely not related to Java itself. It's just a clash between two algorithms inside TCP stack. It's possible to happen and maybe not happen. It depends on packet size, a lot of different things. But if it happened, we get such things. Just the first alarm, some beep, which make you careful here, is that here on my laptop, I've got 25 requests per second. And on another Linux, which much more powerful server-side machine, I've got the same 25 requests per second. So probably something with timing, not CPU power, etc. So it's a well-known issue. There are a lot of description how it works. For example, I like that article. And when I fixed and turned off TCP delay, I've got such performance boost. Cool. So the idea which I want to bring you is that in every area there are a list of well-known problems. And sometimes such problems can be not easily to find. That is why you just should know that for that area. No ways to discover that situation with some kind of issue for you with feasible time, with reasonable time, and etc. etc. Okay, we fix that. What we do the second? We have a benchmarks. They works normal time. We need to improve performance further. Remember, I still didn't read HTTP2 specification until that point. I'm just executing the code and working with that. And the first step which I'm doing, I'm just executing profile. I don't care which kind of profile I want to use. It's a fresh code. It's a collecting of low-hanging fruits. So any profiler should be useful at that point. Anything, what you like, I just use my own. It's some screenshot. That is instruction. Extracted information from that tree which I got here. So it's a benchmark which sent 1 byte, which get 1 byte from the server, just 1 byte for initial. And do you see something strange in that profile? How HTTP works? Initially, we sent our request with headers, all other things. Send frames because of HTTP2, everything is sent by frames. After that, I start reading my body of my response. And the key question, if I'm reading body from the server, why I'm sending something here? I suppose that the developers that they named all methods correctly. They named methods what they do. Okay. And it's quite strange. It wasn't clear for me, and it was the point when I started to read HTTP2 protocol. And it was a problem inside. So HTTP2 protocol has some kind of protection for DDoS attacks. It's quite similar for active stream things. So each sender and receiver, they have some flow control window. It's just a number. How they have an agreement about that. And if sender sends some data, some amount of data, sender should decrease that window, but that's a send of data. Sender said again, yet another piece of data, flow control window became 0, that's all. If at that moment sender will set something another, it will consider as protocol error, and that's all. So it's protection inside HTTP2. So how it works? Receiver will process data and show window update. Okay, I'm ready for next 8K data. That's increased, and it can be done. So how it's written, it's one part of HTTP2 standard. So if receiver frame sends window update, and it's consumed all data, then we're updating things. Okay, how actual code was written according to that specification? So we get data frame, we process that finally, we have that frame processed, and we take a length of our data and send two windows of data, one for that particular stream of data and another for the whole connection, like exactly according to specification. It means that when I receive 1 byte from server, I have to send 2 frames back to the server. It looks like a little bit weird. After some more careful looking into specification, in another part, so that sentence, it was here. Somewhere in another part of specification, there is another things. Where it's written that HTTP2 standard didn't force you how you send that window update. Okay, hey, we have a freedom. We may optimize it somehow. And what we do? The first modification, first of all, some part of logic moved to another case, and here there is one minor optimization, which means if we received end of stream, end of data for that particular stream of data, we shouldn't send window update frame back for that. Why? Data is finished. No more data is expected. Just let's save 1 frame. And the other things that we accumulate our window control data and didn't send signal back to server each byte to each data. Just choose some kind of threshold and send it back when we accumulate a lot of data processed. Just practical experiment shows that the best performance achieving when threshold is somewhere near the middle of our window control. And just these two, it's two modifications here and here, just with some round of class around. And it gives us yet another 23% of performance. That would be nice. So here I would make some conclusions that specification could be unclear. They can contain some contradictory sentences. You should be careful reading to that and use your mind to do that. Any question at that moment? Okay, let's go further. Guys, please raise your hand who is working on the single core machine right now. Okay, not in our time. So what we have to do? We have to think about scalability of our programs, of our applications, of our libraries. We have to make it working on many cores. Then many cores we are scaling, then better. Okay. We are taking our client and measure its performance. X-axis, it's just amount of threads. Y-axis is throughput. And I see that, okay, scaling from 1 thread to 2 thread to 4 thread, perfectly, ideal scaling. After that, everything is stopped. We should fight somehow with that. Again, we should execute some profiler which could show you thread contention. I have some kind of profiler in my toolset, but believe me, 90% of cases with scalability I could fix only with that script. What I'm doing here, I have my benchmark. I'm executing my benchmark with 4 threads, collecting, redirecting everything to some block file, and just sending -3 signal to my VM, which means just print stack trace inside that log. I did it for several minutes, and after that I'm just processing, I'm extracting which all that stack traces, in which state threads exist here. Also, just 2 command lines. I've got it. So what I'm interested in here is block it. I don't interested in to find where it's runnable. Runnable is fine. It should be runnable as much as possible. I'm not interested in waiting because of it's some kind of condition, which of course should be evaluated, but at different kinds of logging. First of all, and the simple things which I could look, it's a blocked block. Okay, where is blocked? Just another script, a simple grep operation. Sure. The first one? Yeah. That one is just parameters for my benchmarking. It's not interesting. The key question is just redirecting to log and just send signal to that process. And here, just grab all thread states, sort them, merge unique lines, sort again by numbers, and I've got that number. And I'm doing here the same, just show me the next line after blocked state. And I found that almost all block operations are from one single method. It's my blocking point. It's time to look into code. So what I could see here is a code for that operation. First of all, it's a global log. It's a global log for that connection, which prevent my client to be scaled. Let's consider all operations inside that code, trying to understand, is it possible to move something outside of that log, to reduce the time of that log, or whatever, what is inside. So just here's the code. It's just initiating of request. In sending the first request to the server. So we are creating headers, we are assigning like all other structures, and we send the first initial percent of data. All other communication with server, all other frames, they are here. So that method takes more than 50% of time. That method, register new stream, it takes only 1% of time. But it's quite important issue with HTTP2 standard. Because of register new stream, what really do, it assign a number for a stream. And if I assigned number 9 and number 11 for two streams, for HTTP2 standard has a very bad limitation. I assign two numbers. It means that the first portions of data, first initiation request for that numbers should arrive to server in that order. So 9 should arrive before 11. If 11 came before 9, it will be error. I don't know why it's fix it in the standard, but it's reality which I have to work with. Okay, so it's a problem. Numbering here is a problem. Here is just encoding header. It's so-called HTpClient protocol. It's different standard, but reference from HTTP standard. It takes 80%, and here's another problem. It's a very nice header compression. I saw examples when 8 kilobytes headers with a lot of fields were shrink into 20 bytes. It significantly reduces traffic. But such kind of compression could be achieved only by some statefulness. HTpClient is a stateful protocol. If you have request 1, 2, 3, and you compressed for that request, and that in 1, 2, 3 order, it means that decoding of that header should be performed in the same order. Header protocols, just decoding won't work in that situation. And according to that, you should provide proper order of sending that request. Otherwise, it won't work. Okay, encode frames, it's very, very simple thing. It just takes our internal structures which we use in our client, which represent frames, and converts them into byte buffers which we are going to send. And here is just simple writing to socket. It's just very simple wrapper around writing to socket. That's all. It's a decomposition of that method. How we could improve that? Let's do the first step. Don't change the algorithm, the preserve, how it works, the preserve ordering of old byte buffers. We usually call it conservative optimization. I even should know how it works and details of specification. Because of the key problem is here, write buffers inside of log. Why it lets us not to create a queue, put all byte buffers in the right order into that queue, and another thread process it? It's okay, our client is asynchronous. Let's do it. Cool. The size of our critical section became 60% less. We got some performance speed up. But it's time to move a little bit further. First of all, the HTTP2 standard has a restriction for frame order, for other ordering, but they're not totals. It's not so strict orders. And we have two kinds of ordering. First of all, it's how we send our frames. For example, there are some limitations. We have sent header frame, data frame, but etc., etc. But for example, window update could be sent at any time independently with other frames. And the other issue at byte buffer source. Again, according to our implementation, the single frame could be converted into several byte buffers. We don't want to spend time and resources to copy that information inside single byte buffer. It means that if I have several byte buffers which represent the single HTTP2 frame, if I interleave with other byte buffers, the server can decode. We provide automation here and here. So let's do the same, the second changes. First of all, we operate not a queue of byte buffers, but we are operating with queue of byte buffer arrays. Or it could be list of byte buffers, doesn't matter, set of byte buffers. Here, that set of byte buffers, it's atomical operation. we should interleave, insert something before that sequence or after that sequence, but not inside. It saves us from the situation when we encoded one frame several buffers and we don't insert anything inside here. Cool. And the second idea, instead of queue, we are using dequeue and change the whole idea. First of all, some frames which have priority, like window update, we just could insert at the beginning. We could insert it in any place because of all atomicities here, but the chunks. And here it provides less blocking, and even we could receive better performance results, better response from server. And these two modifications provide us such kind of improvements. So I'd consider that scalability just improved 2.5 times, from 10,000 requests per second till 25 and higher. Much better. Okay, and again, even writing some program for my clocks right now, I have to think about scalability. Too much cores around us. We should think about that everywhere, every time. Okay. And the last issue, the last thing which I want to say is about pooling. Do you know what object pool is? What's the purpose of object pool? Okay. What if that object is not expensive for construction? A lot of people are using object pools to avoid GC. Okay, if creating an object is a very expensive operation, pooling is required, for example, TCP connection. But unfortunately, I've seen a lot of, in my experience, a lot of examples in Java and etc. When people think that garbage collector could cost, if I'll create a lot of objects, it will cost. Let me reuse that objects. That is why people are using objects pool extensively. So, and the first question: do we need a byte buffer pool for such kind of HTTP client? What do you think? Okay, it's a very nice point, because of you hitting 20% of people, which said that. Other 80% of guys who are using pools usually said, okay, we know that pools are required, particularly for such crap as byte buffer. We'll write pool. Okay. So there is some urban legend that having byte buffer pool is a very nice idea. Some people saw maybe Native's blog post, which was done 3 years ago, how they put byte buffer inside native infrastructure. They got a very, but it was their pool in their library. It means nothing for your code. Why we should do that? And okay, memory is expensive. Let's try to do that. What we got at result? At some moment, we have some kind of byte buffer pool inside our HTTP client, but it's an idea. Let's put pool inside. Let's provide a public API for client, which allows to end user to configure that pool somehow to provide his own byte buffer, etc., etc. What we got results? First of all, it's not implemented. Pooling is a performance feature. It's not provide any kind of functionality. Nobody care about that when you are working on the first stages achieving working functionality. It's not a functional feature. So of course people did some skeleton for that, but not start using. And at that moment, what we have? We have only one byte buffer from from 5 buffers are returned to pool. And it's really an issue because of everything is synchronized, concurrent application became slowed down. Okay, so it should be done somehow. And in reality, we have only 2 alternatives. We may get rid of completely of our pools, let GC working. GC already exists, it could do something. Or maybe it makes sense force to provide a normal implementation of that our byte buffer pool and to check what is better. So we are starting to do it. And again, the first question here, which kind of buffers we should use, direct byte buffers or heap byte buffers? And who knows the difference between direct byte buffer and heap byte buffer?
Well, one is allocated on the heap and the other is not.
So direct byte buffer is allocated is native memory. So maybe it makes sense in general thoughts, just I'm thought. Maybe for direct byte buffer it makes sense to make some kind of pool because of heap won't perfectly well doing with that. But again, as I told, in performance everything should be checked with experiment. Let's do the experiment. Oh, let's finish our theoretical thoughts before. Just looking into code of GDK, I understand that direct byte buffer is much better, theoretically much better than heap byte buffers for all input-out operations. Just because of if we have heap byte buffer, before any kind of networking operation, we copy that data into direct byte buffer, because of operating system should work with that. Okay, if we are working with direct byte buffer, we are avoiding extra data copying. Theoretically, it's better for input-out. But there is another situation. There is an encryption. There is SSL engine. And for HTTP 2 protocol, using encrypted connection is standard de facto. So we have to use some SSL engine. Okay, let's check. Just dig into code of our SSL engine. And somehow we could find that our SSL engine works directly with heap byte buffer. But in case of direct byte buffer, we initially have to copy that data from native memory to Java heap, encrypt it, and copy back. So here, heap byte buffer is better. Again, it's theoretical. Let's check it. We did some check and realized that there's no difference at all. From my point of view, here I even took in quotas because of 0.1%, it doesn't mean fast. So why we should care about direct byte buffers, have complexity with native memory, and thinking about everything. Heap byte buffer will be enough. Okay. Let's do the following. Let's implement completely, fully normal pool version. We avoid synchronization in pool itself. Just switch to concurrent structures. It doesn't eliminate completely synchronization bottleneck, because of concurrency also costs, but it's very highly optimized for that. Anyway, it works without blocking. Of course, it creates problem with scalability, but not so huge as in case of scalability. You pass through the all code. You find every byte buffer and achieve to return the byte buffer back to the pool. Don't lose it. If you want to pull, it means everything return to that. We optimize it by size. In reality, it's just after some work, it happens that our client just needs 3 kind of size for 3 sizes of byte buffer is actual. It's size of frame, it's size of that data frame, and the size of encrypted packet. Everything is not real. And what we get here? Of course, there is a very huge advantage of pooling version. It's less GC allocation pressure. It's as intended. What we have as disadvantages of that approach, first of all, it's very complicated code. So we have a byte buffer. We have to track life of that buffer. We can't copy that buffer into two references, and at which point we will return into that pool. We should provide a lot of stuff for that. And particularly, we can't use like nice byte buffer methods like slice and rope, which share data between different byte buffer, because of it kill all idea of pooling data. We have to track it. So it's definitely complex code. And we did the second implementation, no pool, completely no any kind of pools. Code became simpler. We actively share buffers everywhere where it's possible to split it, slice, wrap, etc., etc. And again, quite nice, simple code, quite sim public API. I love performance feature, I like configurability, but if you're making a library, and in your library there are public methods or parameters of method, because something in API that did not expand your functionality but works only for performance, I strictly against that. It's limitation for you, really, not an improvement. The only thing we have is allocation path. Okay, let's check how it works. So baseline, as baseline, I will quote here the original incomplete version. We have incomplete version, where some buffers return to pool, some not, total mess. Okay, let's check what happened with these two versions when we start working with normal implementation. And of course, version with pool consume much less memory, but the version with completely no pool also consume less memory, just because of it was completed. It was done. It wasn't incomplete thing. In both cases, we have less allocation rate. It's not a performance, it's improvement for allocation rate bytes per operations. Doesn't matter at all. I just sit and check total GC pools time in all cases, and I see that baseline took 1.5%. Total pool version use 0.1% of time, and no pool 0.7. Who cares about do we have an object pool or not? And here is the performance improvement which I achieved for both versions. And again, version with no pool slightly higher performance. They're comparable with performance boost. Here is the ranges because of at that moment we have hundreds benchmarks and it's just covering different scenarios. It's our speed up. And what I just have to say here. First of all, don't believe in the urban legends. And the other thing that any finished solution is better than something incomplete. We had incomplete version. It was very awful. Okay, we have only 5 minutes left, so I'd like to show you some results with comparing with Jetty. I could compare with anything. Which we got finally, it's a different size of data, it's a plain connection, an encrypted connection, it's a different amount of threads, it's a GET request, and it's a POST request. Somewhere our client is faster, somewhere JT is faster, and I'd like to say, is my general consideration that performance of them is comparable. So I think we achieved a reasonable performance with reasonable efforts. With that was our goal. Done. Questions, please? Yes?
Did you benchmark against Netty?
Excuse me?
Did you benchmark against Netty?
No, we did not benchmark against Netty. We didn't benchmark against anything in that moment of view because we did not compete with them. We did not, and we don't compete with Netty. We don't compete with HTTP. We don't compete with Jetty. We just checking how it works. It was not our goal to provide a high-speed performance. It was our goal to provide reasonable. Because of if you need to provide a high-speed performance, the first thing which I will do, I will do the same things as Netty did. I will rewrite byte buffers. In that project, it's separate module. It's module java.net.http. It's different module. I'm using Java-based module, but I can change them. The goals of scope of my modification was only inside that module. In that situation, I was the same. It doesn't means nothing that I'm from Oracle. I was the same consumer of Java public API as you, and I wasn't able to change that. It was just rules for that project. And honestly, I have to say that there are discussions. Unfortunately, I didn't track that last time, but there is discussion. They're significantly initiated by Netty guys to improve byte buffer performance, how they did. And I hope somewhere in the future it will be done. I'm just, unfortunately, don't know the current status of all that discussion. We definitely know that these things, byte buffer, some basic things which out of scope HTTP client, they should be improved. And activity here is not a zero. No more questions? Thank you.